Hello, it's Keith here, and this is lesson 2 of the SuckShoot series of my 6809 assembly programming tutorials. SuckShoot is the game you can see here. It's a basic little shooter where we have bats fly towards the screen. We need to move our crosshair over the bat and shoot the bat before the bat gets to the front of the screen. If it does get to the front of the screen, it will bite us and it will deplete our life. Now, this game has been sort of written into sections. It was originally a Vectrex game, but I've written some new graphics routine as I imported it to the Dragon. So that's what we're going to be looking at today. We're going to be looking at the Dragon exclusive code. Now, some of the other parts of the code, the range checking, the random number generation, these were also covered in the multi-platform series. So we're not going to be covering those again today. It's just going to be the Dragon code we're going to be looking at. Okay, well, let's go over to the source code and let's take a look. Okay, so here is the source code we're going to be looking at today. It's Dragon SuckShoot we'll be looking at this time. And we're going to be going over the code. Now, you can see we've got a variety of variables here at the top. These are the variables that store the position of the player, the enemy, some of the things that the game needs, and these are all in RAM. Our game is actually running from a ROM cartridge for convenience. It's the easiest way to get code running on the Dragon. And you can see here, we've got our screen mode setup routine here, and this is the same as the Hello World example I did recently, and that's because the Hello World the bitmap code that did a bitmap font is the code that's drawing the text graphics in this game. So we've got our code there, and we also have at the bottom our sprites. Now our sprites are exported with Sprite editor. There are 7 sprites in total, and that's the bitmap data there. And then we have a lookup table of the memory address of each sprite and the width and the height in pixels. Now these were all created with Sprite editor, and you can see Sprite editor here with the bitmaps. You can see here is the crosshair bitmap. If we just go to next sprite, you can see there's 2 frames for the different 3 scales of the bat, and so we need to calculate the memory address of the bat accordingly depending on its current Z position, how close to the player it is, and of course when it gets to the front of the screen it will hurt the player. So that's our sprite routines. Well, let's start at the beginning and let's take a look at the title screen routine. So when our code starts, we first clear the high score. We're just writing 4 bytes of zeros here to the high score. And then we are starting the title screen here. We've got a clear screen routine to wipe all of the memory of the video memory. And then we are waiting for the release of the fire button. That's just a timeout there to wait for the fire button to be released. And then what we're doing here is we're going to show some text to the screen. Now the Y register here points to the memory of the text we want to show. And the D register is the X and Y components there. So 03 is the X position and 00 is the Y position. So we're showing the text SuckShoot here. If I just select that and I do a Control F here. So here is the SuckShoot text, and you can see here's our SuckShoot, and this is a 255 terminated string as I usually use. You can also see while we're here, we've got an addition for the score. This is binary coded decimal. So this is to add 5 points to our binary coded decimal score, and we'll see that later on. Okay, so that's the first of the text strings. We've then got a high score text, which just shows the word high score. And we're then showing the high score in binary coded decimal. BCD show was covered in the multi-platform series. We're then defining the X and Y position of our bat here, and the scale, which is the Z position effectively, and the sprite number here. And then what we're going to do is we're going to show the bat onto the title screen, and the bat will appear in the center of the screen, and it will flap up and down as we wait for the fire button to be pressed. So here is the start of that title screen here. We are then just toggling the enemy sprite number. This is toggling between the 2 frames of animation here, and we're showing the enemy here. Then we're pausing for a while, and then we're showing the enemy again. These are XOR sprites, so showing the enemy twice will effectively remove it, ready for the next loop of the title screen. We're then reading in from the joystick, and we're checking the first fire button. If the fire button is not pressed, we're bouncing back to the top of the title screen routine and showing that sprite again until it is. Okay, so here is the start of the gameplay. So we're clearing the screen again, randomizing the enemy position using the random number generator that we covered in the previous multi-platform episode. We're setting the number of lives for the player here. We're setting the score to 0. and then we are setting the X and Y position of the player, and we're setting the default speed of the enemy, because the enemy will get faster as the game progresses. And then what we're doing here is we're showing the initial score and the lives here. Okay, so now we're on to the main loop of the game. So first what we're doing here is we're checking the sound timeout. Now the sound effects are done by my simple Chibi sound driver, and this will basically play a sound, and we were just waiting for a while to silence the sound and stop it. So what we're doing here is we are waiting until the sound timeout reaches 0, and when it does reach 0 we pass that 0 to Chibi sound, which stops the sound. We're then showing the player and the enemy sprites there. We've got 2 routines to do that. We've got a delay again. We then remove them both again because this is XOR, so showing it twice will remove it. And then we're loading in the X and Y position of the player, and we're using the read joystick routine, and then we're checking each of the buttons and the current position of the crosshair, and if the crosshair is not at the edge of the screen, we're moving in that direction. Now this is basically the same code as we covered in the simple series. It was copied straight off it, so there's not been too much change here from there, and this is just a simple routine for checking all of the directions of the joystick and moving if the sprite isn't off the screen. We're then checking here if fire button 1 is pressed, and if it is, we're going to do a series of things. We're going to make a firing sound. We're then going to check if the player is within range of the bat, i.e. if the player has shot the bat, and if they are, we're going to kill the bat. So we're making a different sound if the player kills the bat, and then we are increasing the enemy speed, so the next bat will be a little bit harder, giving the enemy a new position, and then we're giving the player some score. 4 is the length of the 2 binary coded decimal strings here, and we're just adding that score value of 5 to the score, and then we're updating the score on screen. Now if the player hasn't pressed fire or hasn't shot, then we're going to carry on here. We are updating the new XY position of the player. We're then updating the current movement of the bat by the amount of speed that the bat is currently moving by, and if needed we're making the bat bigger. If the bat has got to the front of the screen, which is 64, then the bat has hit the player, and what we'll do then is we'll reposition the bat, we'll make a sound because the player has been sucked, and we will decrease the player's lives, and if the player has run out of lives we'll go to the game over routine. Otherwise we'll update the score because the lives are shown as part of the score. And then finally we're here at the main repetition here, so we're just looping that whole sequence again. Okay. Now we've got the update score here. It's very straightforward. We're just locating the top left, and we're using BCD show to show the score, and then BCD show to show the lives here. We'll have a look at the game over in a moment. What I want to do next though is look at the show sprite routine. So the show sprite routine will use that lookup table once again. So here's that lookup table, and you can see we've got 2 bytes, and this calculation will effectively calculate the memory address of the bitmap data, which is in the raw format of the screen, and then we've got a width and a height in pixels. So each entry in this is 4 bytes, and the size is in pixels, which might not be what we actually want, so we will have to convert it. Okay, so here's our show sprite routine here. What we're doing here is we are loading into X the memory address of our sprite data. We're then loading the X width in the accumulator here to offset by 2, and we're then effectively converting that to bytes by shifting to the right twice because there's 4 pixels per byte. So we've now got the width in bytes. We're then offsetting our sprite, centralizing it here so that we are drawing our sprite in the center of the position that has been calculated. We're then doing the same for the height here, but we don't need to do any kind of shifting to the height because the height is already in lines effectively, and that's what we want. We're then just centralizing that again. We're using a get screen pos routine which will calculate the VRAM address for an X and Y coordinate. And then what we're doing here is we are transferring all of the data from our X source to our VRAM in Y. We're transferring all of the bytes for a line, moving down a line, and then we're repeating. And if you've seen the simple series, you should recognize that because it's basically the same routine as the simple series. So that's our sprite drawing routine. Now for the player's target, we just select the memory address of sprite data because it's the first sprite we want. We then get the X and Y position of the player sprite, and we run show sprite to show it. Show enemy is a little bit trickier. We need to take the enemy scale and we need to convert that to either a 1, a 3 or a 5, and the reason for that is those are the sprites for the 3 different scales. We then take our frame number here in enemy sprite, and this needs to be a 0 or a 4, and then we add that to our frame number, and this will calculate the correct offset within the sprite data for the bat sprite that we want to show. So we're just adding that up there, and that now points the Y register to the address of the data of the lookup table for the sprite we want to show. We're then just getting our X and Y position of our bat sprite for our enemy, and we're showing the sprite to the screen. Okay, so that's our sprite drawing routine. Now finally, let's have a look at the game over routine. Well, this is pretty straightforward. We're waiting for the fire button to be released because we don't want to end the game over screen before the player saw it. We silence the sound, we clear the screen, we then show the game over message at the top of the screen. And then what we're doing is you're using BCDCP, which is a compare routine, and we're comparing to see if the score is lower than the high score. And if it's not, then we're going to announce a new high score. So here we're transferring the old score to the high score so that that is stored. And then we're going to show a string to the screen. So we're either going to show the got high score message, or we're going to show the got no score message. And if we've got a high score, we get a very positive new high score message. And if we didn't, we get a very negative you suck message. So a bit of fun there. And that's just going to branch either showing the high score or the no score message. And then finally, all we're doing here is we are waiting. We're reading in the joystick and waiting for the fire button to be pressed. And when it is, we jump back and we show the title again. So there we go. So that's all of the code we're going to be covering today. Now, this game was originally a Vectrex game, and all I had to do to convert it to this system essentially was change the graphics routines. Chibi sound and things were already ported, so that wasn't too bad. You do have to tweak a few of the minor things, the movement speed of the cursor, the boundaries of the screen, and also depending on the width of the screen you need to change the font drawing routines, but it's not too difficult. I actually this morning ported this game to the FM7, which is a very different system, and once I'd got that sprite routine done and a few other sort of minor issues, it was all fine. So it is pretty viable to port this to other systems. So yeah, anyway, that's all we're going to be covering today. You can go to my website, you can download the source code for this game, you can have a play of it yourself, and as I always say, you're welcome to take the source code and make something of your own out of it, even if you want to do that, even if you manage to do that commercially. If you manage to make some amazing game and make $100 billion, you don't need to give me any of that. You can go ahead, I'm sure you've earned it if you manage to do that. So there we go. Anyway, if you like what you've seen, please like and subscribe, because if you do, then there will be more Dragon content in the future, and if I don't see people enjoying the content, I won't make it anymore. So make sure you're liking and subscribing if you liked and want to see more. Anyway, hope you've enjoyed this today. Thanks for watching, and goodbye.